Hello, this is part two of our inverses video. So in this video, we will be using Python to create an inverse function program that will compute the inverse of a function, verifies if two functions are inverses, and graphs a function and its inverse. This will be a little bit different though than the other programs. I will not have a main function that we call at the end and it'll take all the functions and does the computations and so on. We will just have a main block of code. So no main program, no main function there. And another thing is we will hard code our the expressions um, that we want to take the inverse of or check if they're inverses and whatnot. Also, as well as graphing, we will hard code say two functions and then check their graphs compared to the line y equals x, which verifies if two functions are inverses. That's how we tell if two functions are inverses, if they are reflections over the line y equals x. Anyway, let's get into the VS Code. Well, actually, let's go over it, the pseudocode of the program really quick. We have a main print menu that will be that won't be a function. Um, it will actually be a function. Yeah, sorry. It will compute the inverse. We will ask the user, give them a choice to either pick an option for computing the inverse function, verifying if the functions are inverses, or graphing. And then we will have those options as functions of themselves. And then the main block, we will be doing all of these other things down here. So we are going to be using symbolic math math objects that we will call simply later to do that. And we will that's how we are going to check the inverse functions because they are linear functions in the term of y equals something times x plus or minus a value. So that's how we do that. So let's go into VS Code. I have created a comment that this says that this is an inverse function program, and I've saved the file as inverse of a function. So let's go ahead and put in all of our functions and all of the methods I need to. right, so I've created my program. I have imported simpy, and then I've also imported numpy, imported math and matplotlib as PLT, and now I've created the functions I talked about, the print menu that is an option given to the user to choose from, and then the second function is compute the inverse. This one it says xy equals yx. That's switching the variables, and we solve an equation in terms of y for x, and then we take the first of those solutions from a list, and we print that solution. That's what that inverse function does. We compute the inverse this way. And then we have the check inverse function. This one has a symbol x, and then we call a bunch of other functions. I made my composition of functions program earlier. I may show you that program in a minute. This computes only the composition of functions. So whatever that program was, I copied and pasted into here, but I did change this command starting from the if statement. If these things are true, if f composite g of x equals g composite f of x, then we say the functions are inverses. Otherwise, they are not inverses. So this is what this function does. It checks if the two functions are inverses. And then lastly, we have the graph inverse function. These are all variables that we want to graph. So f is one of the expressions the user would like to check the graph of, but we are not gonna input it as a expression or anything. It's already been hard coded. G is another expression, but G may or may not be the inverse. So that's the question we want to answer. Is G the inverse? And then h equals x is the line of y equals x, but in this case it's called h. And then I've also created this array or vector here. This is just a range from -10 to 10 increments of 1. So x are those values, and then let's see, we plot f, g, and h with those values that we are picking, -10, 10, and 1. And then these are the colors there, and then the line style for the line x equals h is dashed. And then we have ax v line. So those are the axes. We want to show the axis to the screen, and then we call plt-show, and then this is how we run our program. This is our print menu and a choice, just like the other programs we've created. And then if the choice is 1, we call the compute inverse function. It does the computation, and we set flag to false. If choice is due, we call the check inverse function. That's the confusing big function that I talked about that has the composition of functions in there. We call that, and we check if they are inverses or not, and then we set flag to false. And then lastly, if the answer is 3, then we check we graph the functions based on the function. We call that function graph inverse, and it has these variables as parameters that we graph in there. So what I need to do is I need to have a way of keep running our code. So let's do that. All right, so that's how we break out of the program. We made another choice for the user if they want to quit the program. If they hit Y, then the program breaks and we stop running the program. All right, so I'm gonna quickly check if everything is looking okay, and I'll also find my composition of functions program to show you how the function I created, this function down here, compares to it. All right, so we're back, and this is how the function composition program I talked about earlier. I created only this composition of functions compares to the function we made for checking inverses. It's very similar. It does print. The only thing it does here, though, it prints if the composition of function gives us the identity function x that we talked about in part 1 of this section on inverses. We said that f composite g of x has to equal x, and g of f of x also has to equal x for them to be inverses. And that's what this function does, or yeah, this program. If I run the program, it tells me that f of g of x is x, and g of f of x is also 1 times x, which is x. And we could print another line saying, therefore, the functions are inverses, but I will do that later. So this does a good job in finding if the functions are inverses based on a hard code of two functions. For example, I can change this one to x plus 4 and then g of x to x minus 4. I just change it to x minus 4, and if I run the program, we should get the same answer because these two are inverses. So x plus 4 and x minus 4 are inverses, and we can tell because their compositions give us x. All right, so that's where I got that part of my code from, is from another program I made before. So let's run the program, and I've also have my book open to look at some problems from the book. So we'll look at we'll test the program for this problem here, number 33. The g of x, in this case, f of x is 2x plus 8, and see what we get. So I've already entered 2x plus 8, and when I run the code, we'll choose number 1, and then we get x over 2 minus 4, which is what the book is getting. We can check with x minus 5, but we know it's going to be x plus 5. So let's test this one, 3x plus 4, see if we get the same answer. So we'll hard code, say yes, and we'll test 3x plus 4. See what we get. And then run the program. Choose number 1, and we get x over 3 minus 4 thirds. 3x plus 4, 3x minus 4. So we know that these two functions are not inverses, those pairs of functions, 3x plus 4 and 3x minus 4, because the inverse of 3x plus 4 is x over 3 minus 4 thirds. Let's keep running our code. Let's check number 2. It says the two functions are inverses because if I go back up here, I have 2x plus 1 and x minus 1 over 2. So I know these two functions, if you do the math, are inverses. Likewise, if we said x plus 1, x minus 1, this would also be an inverse. If we run it and hit number 2, these are inverses. But say if we had 2 times x plus 1, 2 times x plus 1, like that, that's fine. So if we run it now, say no, and choose number 2, let's run it again. So hit number 2, and it says they are not inverses there. So we can quickly check many functions if or not they are inverses just by typing in this, coming to this line of code where I have def f of x and g of x, where they return the functions we want to check. I'm going to test number 3 of our code, which is graphing. So if I hit 3, let's hit T and then hit number 3, it'll give us a nice graph of two functions, and the line y equals x. It's a dash line, and I've color-coded the other two functions. And in this case, they are inverses because they're a reflection over that dash line. So let's look at why. So if I go to my graph function, the two functions are 2x plus 1 and x minus 1 over 2. And these two functions are inverses. If I entered, for example, x plus 1 and run the code here, hit number 3, notice that the graph has changed. They're not nicely reflections over the line y equals x. So we know those functions are not inverses. But let's exit that, and let's put x minus 1 only. X plus 1 and x minus 1, and run it again. So when I hit number 3, those two functions are inverses, and we can change the window from, let's go back. If we wanted to change the window, all we have to do is change it here, the x limit and y limit. All right, so that's how we create an inverse function program using Python. Thanks for watching.